Hi guys, welcome back to my channel. It's the Educator here, and I hope you guys have been enjoying this crash course series that I started a few days ago. Alright, so in this video, we are going to be doing CHM101 possible questions. Alright, and as usual, I have divided it into sections. So just in case you are just joining in and this is your first crash course video that you are going to be watching, alright, please do well to hit the subscribe button. I created a crash course video for MTH102 and then Bio 101, but if this is your first, you're welcome. Do well to hit the subscribe button so that subsequent crash course that I'll be dropping, you get the updates on time. Alright, so like I said, as usual, I have divided it into sections, and for CHM101, I've divided it into 3 sessions. Alright, so in this session, we're going to be treating atom and molecules, periodic table and electronic configuration, hybridization, chemical bonding and chemical reaction, and finally, radioactivity. Okay, so let's get started. So in other sections, like I said, I divided into 3 sessions. In other section, the second section is acid, base, and salts, other topics, right? Then the third section is for electrolysis and oxidation and reduction. So in the third section, we're looking at electrolysis and then oxidation and reduction. That's redox reaction. So I'm going to be dropping this video like I used to do based on the engagement. Okay, so for the next section to be dropped, it means that this video needs to hit a particular number of engagements for me to drop the next video. And as usual, I am not just creating videos with possible questions, I've also created files for the crash course. So just in case you want to access the crash course, as usual, do want to reach out to me on WhatsApp. So let's get started. Atoms and molecules, the simplest. In fact, if you see any question on the day of your exam under atoms and molecules, you should be able to do so well. All right, so let's move on. Question 1. Which of the following laws states that a pure chemical compound always contains the same element combined together in the same proportion by mass? Once you see this kind of question, once you see, because in that crash course, the first thing that you will see when you look at atom and molecule material is the laws, right? The combination laws, how atom and molecule combine together. There are laws that guide them. They are not just combining like that. There are laws. And now, in this particular law, once you see that something is common, if you see same element, and then you are also seeing same proportion, constant proportion, fixed proportion, the answer to that question or the answer to that law is law of constant composition. So this is the law of definite proportion also, or constant composition. All right, so a compound always have fixed composition regardless of the source, okay, regardless of where it come from. So for example, if a compound is produced from water, for example, if it is AB2, for example, a compound is produced from water and that compound is AB2, AB2, this is the compound. If the compound is produced from urine, it will still be AB2. It will not be AB3. That's the meaning of this law. Okay, so once you see this proportion by mass, same composition everywhere, just choose constant proportion and then move on. So this gives you a clue that you must know all the laws, not only this one, right? So question 2, in Rutherford alpha particle scattering experiment, this is another area of concentration that you must take note of when it comes to atom and molecules, the experiments that were conducted. In Rutherford alpha particle scattering experiment, the fact that a few particles were deflected at very large angles proved. So let me tell you the experiment and then we answer the question. So this is what happened. So Rutherford conducted an experiment, and then let me say this was the medium, or this was the substance he used. Then from a distance, he projected alpha particles. So let me say from here, he projected alpha particles. So some alpha particles were coming like this. Once they hit a particular place, it will deflect. So some of them deflected like this, right? Some of them deflected like this. Some of them deflected like this. But then there was a very wide range of deflection. Why some of them just passed like this, just entered straight and passed straight. So something now happened. After he conducted his experiment, he now discovered that he concluded that for these particles to be deflected, because one thing you take note of is that alpha particles are positive, right? We are going to do radioactivity in one of the sections. Alpha particles are positive, which means that for it to deflect, it means that there is a like ion there. So more like positive ion is also in the center of this particular substance. So because it's in the center, which means that the center has a positive charge. the center has a positive charge. Then those ones that pass through, he just concluded that it's either they don't have a charge or then there is an empty space there. So now, in Rutherford's alpha particle scattering experiment, the fact that a few particles were deflected at a very large angle proved that, from what I've explained, proved that the existence of tiny dense positive nucleus. All right. Next question. Which scientist is credited with the discovery of the electron using the cathode ray tube? It is J.J. Thomson. So J.J. Thomson discovered electron using the cathode ray experiment. Once you see cathode ray experiment, just know it's electron. Once you see once you see carnal rays, know it is positive particles. All right. So please take note of that. Next question. What is the number of neutrons in magnesium? This is another interesting question that you are going to be seeing on the day of your exams. Like magnesium can be another thing, right? You should take note that once you see something like this, for example, AZ and then an element X, always take note that your A is the mass number, right? A is the mass number. And there's something I should take note of the mass number. What makes up the mass number? The mass number is a combination of proton and neutron. Proton plus neutron, right? And then the Z is atomic number. The Z is known as atomic number. Atomic number. And this atomic number is equal to the number of electrons. Okay? It's equal to the number of electrons. Sometimes it's equal to the number of protons and electrons. But then when it is in its ionic state, maybe cation, that's when it is different. Now, if An, that's atomic number, is P, which means that Z is P. So P is equals to 12. Our P, that's proton, is equals to 12. Now remember, we're looking for neutron. Neutron. The mass number is proton plus neutron, which means mass number is 12 plus N. Neutron. What's the mass number here? Mass number is 24, right? 24. So by the time you do the subject formula, 24 minus 12 will give you 12. So our correct answer is A. In order not to go through this process, is because I'm explaining, that's why I'm going through this long process. Once you see calculate neutron, just subtract up from down. Or rather, subtract down from up. That's 24 minus 12. Then you get your answer. It's as simple as that. Question 5. The plum pudding model of the atom was disapproved by which experiment? So basically, what's the plum pudding experiment? So this is what the plum pudding experiment looks like. And the plum pudding experiment was postulated by Thomson. Thomson suggested that in a particular circle like this, in a particular circle, you have electrons and protons, everything mixed together, right? So let me put electrons like this. Electrons like this. So this was what J.J. Thomson just came up and postulated. So in this is postulation, it means that there is no space for neutron, right? There's no space for neutron. It is just electron and then proton. This is what a plum pudding model looks like, and it was postulated by J.J. Thomson. But then Rutherford, remember we solved the question that Rutherford did alpha experiments, right? That experiment is known as gold foil experiment. Gold foil experiment. So after he did that experiment, that's when he now discovered that, oh, this plum pudding that this guy postulated is wrong, because his postulation just shows that it is only two particles that exist. But now I have discovered that for the alpha particles to penetrate and come out of the other side, it means that there is an empty space there, or a particle that is neutral. But then Rutherford did not know the particle. So because of that, this model was disapproved. So what disapproved this model, or the experiment that disapproved this model, is gold foil experiment. And who conducted gold foil experiments? Rutherford. Please take note, all of these questions can be rephrased to any pattern. So it's better for you to understand the concept very well. All right, so the next question. Which of the following is an exception to Doughty's atomic theory? Another interesting question that you might come across in your exam is Doughty's atomic theory. You take note of Doughty's atomic theory. So atoms combine in whole number ratio. Yes, Doughty said that, and it is correct. Matter is made up of atom. He said that, and it's correct also, right? Because it is made up of atom. Truly, atoms rearrange in reaction. This one is also correct. He said that is also correct. So the question is trying to tell us that there was one of Doughty's atomic theory that was later disapproved, right? And that Doughty's atomic theory is the fact that Doughty said that there is atom of the same element cannot have different masses, that they will have the same masses. But then a phenomenon which is known as isotopy, so we have isotope, disapproved that law. So this is an exception, right? So one thing you should take note of is the Doughty's atomic theory, and then those ones that were modified, the modification, those ones that were ruled out, those exceptions, you should know what made them rule it out, okay? So the next question, which law is illustrated by SO2 SO3? Once you see this kind of question, just run straight to multiple proportion. Law of multiple proportion. So basically what this law of multiple proportion is saying is that the same elements can combine together in different ratios. This is SO2 SO3. It is the same element but different ratio. So you can see something like SO2 and sorry CO2, and then you see something like CO. This is still law of multiple proportion, right? So it's as simple as that. So let's move on. Question 8. Proton is approximately how many times heavier than electron? This is a very simple question, a bonus question for that matter. Remember that proton is heavier than electron. You know, electron is 1/1840. All of these things have been illustrated and highlighted in that crash course material, right? And proton is 1. So this is electron and this is proton. So the question is, what are you going to multiply by this electron to give you proton? It is 1180. So proton is 1140 times, sorry, 1840 times, 1840 times heavier than electron, right? If they twist the question the other way round, you should know that the answer is going to be D. So the next question, who discovered the neutron? This one is a bonus question also. The neutron was discovered by Chadwick, James Chadwick. James Chadwick in the year 1932, alright? Number 10, relative atomic mass is based on carbon 12, right? This one is also simple, carbon 12. Next question, if 5 gram A reacts with 10 gram B, mass of product is, this is another law. Remember we said combination, this is another law. So 5 plus 10 is equals to, the question is as simple as ABC, but you see some people start calculating. Only God knows what people end up calculating. Once you see something like this, very straightforward. Okay, so this is just the law of conservation of mass, right? So the law of conservation of mass is that the reactant is going to still be equal to the product, which means that there is no energy created and there is no energy destroyed, right? And that is what brings about the concept of balancing of equation. So if you have something as C plus O, right, for example, and then you're having CO. If this is 2 here and this is 2 here, this equation is already balanced. This equation is balanced. So this is the law of conservation of mass or conservation of matter. Number 12, isotopes have the same chemical properties because when you hear chemical properties, what controls chemical property is electron. So the correct answer is C. Electron is what is responsible for the chemical properties, right? Number 13, particle with plus one charge and 1 atomic mass unit, that's the meaning of AMU, 1 atomic mass unit, plus 1 charge just go to proton. There's no need of thinking twice. But now if they change this question, because they can change the question, they change the question to no charge because neutron too has 1 atomic mass, right? They change it to no charge, you already know it is going to be neutron. All of these things have been highlighted in that crash course file. Smallest particle that takes part in a chemical reaction right from your secondary school days, you should know this, is atom. Next question, electron orbits were proposed by Bohr. So Bohr was the guy that proposed, he introduced something known as quantized energy levels, alright. So if you see something like this in your atomic models, see something like this, na this guy was the one that postulated that. So Rutherford own was just nucleus, then Bohr own is orbit. So all this circle, and sometimes some school of thought regard it as solar energy. So when you see anything solar energy, just know it's still Bohr, it's the same person. In AZX, A represent, okay, we have done this before, I've even answered the question sef. A represents the mass number. Question 17, law of reciprocal proportion. Law of reciprocal proportion. Now, remember, see now, this is the fourth law that we are doing now. I've done 3 laws. This is the fourth one. The law of reciprocal proportion. When you see any law that has to do with 3 elements, maybe for example, A, B, and C. Once you see a law like that, A, B, and then C, just know it's law of reciprocal proportion. But this one now did not tell us whether it is A, B, or did not give us any element. But now you can read the option and know. If you look at option C, ratio of masses combining with a third element, this is it here. So if they give you 2 elements and they tell you that the 2 elements is combining with a third element, that is law of reciprocal proportion. Alright. Number 18, radioactivity proved that atoms can disintegrate internally. Remember that one of Dalton's law, he said that atom is an indivisible particle, but then the existence of radioactivity tells us that no, atom can be divided. Alright. Atom is neutral because, this one is another bonus question, atom is neutral because proton is equal to electron, so it balances the charge, right? Number 20, valency. Good. You're already coming into some interesting questions. Valency. Valency has to do with the combining power. Combining power. So we'll soon get to electronic configuration. If you see something like this, 285, for example, 285, there's what we know as period and there's what we know as group. Now, you can know a particular period and group from the electronic configuration because you'll be seeing questions like that. They'll just give you an electronic configuration and they'll tell you what's the period that it belongs to, what's the group that it belongs to. You don't need to draw periodic table for you to know. Once you count the number of shells, it tells you the period. So how many shells is here? We have K, we have L, and we have M. So we have 3 shells, which means that it is in period 3. Then the valence electron, the one that is always at the last, is known as valence electron. So the valence electron tells you the group, which means that this particular element belongs to group 5 period 3. But then that's not the question, but I'm just trying to like explain it, okay? Number 21, solar system. Okay, I've said this already. Solar system model, it is still Bohr, right? It is still Bohr. Where's my pen? Okay, Bohr. Yeah, let's move on. 22, 11 proton, 12 neutron, 10 electron. What is this? Neutral atom. Is it a neutral atom? Remember we said neutral atom, they will have the same proton and the same electron. If you look at this, proton and electron is not the same, so it is not neutral atom. Is it isotope? It can never be isotope because if it's isotope, they would have given us 2 elements, remember, but this is just 1 element. So it's either a cation or anion. So let's know if it is cation or anion. Now what this means is that the number of proton is 10 and electron, number of proton is 11, sorry, number of proton is 11 and number of electron is 10. How do you now know that it is proton or it is cation or anion? This is just the trick here. What you should be particular about is your electron, not your proton. Proton cannot change. The only one that changes is electron, right? And remember, we said that atom normally is neutral, which means that proton and electron are meant to be the same number. But then now, from what we are seeing here, we see that electron is less. So which means that electron has been given out. 1 electron has been lost. And remember, when electron is lost, is it cation or anion? It is definitely cation. So please take note. AX, A plus, for example, and A minus. So if A is 10, for example, if A is 10, A plus will mean 9. Please take note, don't go and say it's plus, it's addition. No, it's the other way round. Then A minus is going to be 11. Please take note because we'll be needing it. There's a question like that. So let's move on. Not part of the Dalton's theory. Which of the following is not part of the Dalton's theory? Matter made up of atom parts. Atom differ in mass parts. Atom can be destroyed in nuclear reaction. No, this is not part. So the correct answer is C. Remember, it was this modification that cancelled or that made it disapproved, and this is basically radioactivity. Okay, so he said atom cannot be destroyed, not can be destroyed. So this is not part of Dalton. 24, oil drop experiment determines the charge. Oil drop experiment determines the charge, and the scientist that conducted oil drop experiment is known as Millikan. His name is Millikan. He was one that conducted oil drop experiment. There's a formula, E over M. E is charge and then M is mass, right? But then you don't need this. So just know oil drop experiment is for charge and then it was conducted by Millikan. Next question. H 1.50 is impossible because, all right, have you seen any equation that you will see something like 1.5, 2.5 as the subscript? There's nothing like that. It is always whole number. So now the question is, which law is that? The law is definite proportion. Remember, definite proportion says that any element that is combined together, they combine together in a specific whole number, in a fixed whole number ratio. So it can be 1:2, 1:1, 1:3 and stuff like that. It can never be 1:0.5. If it is 1:0.5, do you know what we do as scientists? We times it by 2. Once we times it by 2, it will now be 2:1. I hope you understand this. And so it is as easy as that. All right, so let's move on. So on to the next, periodic table and electronic configuration. Done with atoms and molecules. So please do well to go through that crash course. Please ensure you go through that crash course. Like I used to say, ensure that everywhere is covered. Don't just do the videos, you leave the crash course. Ensure you watch the videos, go through the crash course. If there's any other thing you can do, still do it. So periodic table and electronic configuration. Let's move. Next question, 26. Which scientist is credited with the first periodic table that left gap for undiscovered elements? When they say the first scientist to discover periodic table or something like father of periodic table, the answer is Mendeleev. Mendeleev was the first person, right? And what he did was that he arranged elements based on atomic mass. Please take note. He arranged elements based on atomic mass. So because of that, he predicted some space for undiscovered elements. You can see why he is a father. He just predicted that there's an element that is going to fit here one day, one day, one day, but then he does not know the element because it has not even been discovered then. But then there's another scientist known as Moseley. Moseley was now the one that brought the new law for periodicity, which says that periodic table or elements in periodic table are arranged based on their atomic number. That's why you have 1, 2, 3, 4, 5, 6, and stuff like that. It was this guy. So if you see who is the father of modern periodic table or who invented modern periodic table, it is Henry Moseley. But the origin of periodic table is Mendel. So please take note of those two. 27. The modern, okay, good. See the question here. The modern periodic law states that the properties of elements are periodic function of atomic number. Please take note. But if they say the old periodic law, it is atomic mass. The modern, it is atomic number. Which quantum number, okay, we are coming to interesting topics now. Which quantum number determines the orientation of an orbital in 3D space? The correct answer is magnetic quantum number. So let me quickly tell you the functions of everything has been highlighted in that crash course file. But then let me just quickly comment on the functions. For principal quantum number will tell you the number of shell, right? So if you see any question that says number of shell, just know it's principal quantum number. Then azimuthal quantum number will tell you the shape of the suborbital or the orbitals, right? Then spin quantum number tells you the spin, but then the orientation is magnetic. Okay, so let's move on. What is the maximum number of electrons that can be accumulated in a d subshell? Remember, we have p, we have s, we have p. This is p here, and then we have d. This is d. 1, 2, 3, 4, and then we have f. F is 7. So the orbitals, remember they said d subshell, not d orbital. That's why you must be very, very careful once they ask the question. If they say d orbital, when they say orbital, this is orbital here. This is orbital. One of these is orbital. Everything together is known as subshell, right? So now in one orbital, you know that in one orbital it is two electrons. These are their arranged, right? You remember something like this in chemistry, right? So now the question is for d orbital. So remember I said this is d. So if we arrange it like this for d, we arrange it like this. By the time we arrange, we have two, 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 two. Then we have d, which means that the maximum number of electrons you can see in d is 10. And it is so simple. Anyhow they rearrange the question, anyone they bring that DSP, you should be ready to answer it. Question 30. Which principle states that no two electrons in an atom can have the same four quantum number? It is Pauline's exclusion principle. So Pauline's exclusion principle states that no element will have the same, no electron will have the same quantum number, right? There must be a difference, and most of the time it is different in their spin. That's why you always have something like this. One will be up, one will be down. It just tells you that it is different. It can never be the same. Question 31. The electron configuration 1s2, 2s2, 2p6, 3s2, 3p5 belongs to which group and period? You can see we're from here again, right? Now, when you want to do something like this, it's very, very simple. This is how you do it. 1s2, you circle the 1. How many electrons are here? You have 2 electrons. The electrons are all these numbers up, all these small, small numbers up. Then all the 2, you circle the 2. What's the total? 8, right? 8. Now, here, you circle this one. What we have? You have 7. So 2, 8, 7. 287, right? 287. So now, 287 belongs to which group and period? Remember, I said the period 1, 2, 3. So we already know the period is period 3. So option D is wrong. So now, the group is 7. But now, if you look at this, we just have group 5, group 15, group 17. Now, one thing you should take note of is if it is P, it is plus 10 to the group. Please take note. If it is P, it is plus 10. So 7 plus 10, you have 17. So the correct answer is group 17 and then period 3. So moving on, which of the following elements has the largest atomic radius? Good. So another thing that you must take note of is the periodicity, the periodic functions of some things across the period, down the group, all those things, electronegativity, ionization energy. Please go to that crash course file and then learn it. Okay, so question 32 says, so the answer to this question is A. Now let me tell you the reason why the answer is A. The reason why the answer is A is that atomic size decreases across the period. Okay, atomic size decreases across the period. So if you look at this one now, we have 281. That's sodium, magnesium, aluminum, silicon. So it's more like 11, 12, 13, 14. If you look at this one is like, let's say closer. If you have periodic table like this, you will see that you will find sodium in this part. So other elements will now be here. And the trend is from here to here, it is decreasing, right? So there's a decrease like this, which means that the ones here, we have higher atomic radius. All of these things have been explained in a simplified way in that crash course. So please do well to check it out. 33. Degenerate orbitals are orbitals that have the same energy. Those are what we call degenerate orbitals. All right. So when you hear degeneracy, degenerate orbital, the rule that talks about it is Hund's rule. Remember, we have three rules for electronic configuration. So it's the Hund's rule that talks about that. Okay. Correct ground state configuration of copper. Good. This question always comes out. Copper and chromium. You see these two guys, there is an exception to these two guys. Copper and chromium. Chromium is 24, copper is 29. Now, what happens here is that the electronic configuration of copper and chromium is stable, right? Copper is fully stable, chromium is half, like the stability, it is partially filled. So what am I trying to say? Remember the last set of elements, please you should know your elements, first 20, in fact first 30 elements. If you are going for examination CHM101 precisely, you must know the first 30 elements and their electronic configuration. So you have 2882 calcium, right? The next one will be 2892, right? And it continues 28102, 28112, 28122. Now take note, in 28122, this is meant to be chromium. This is meant to be chromium. Let's calculate it first to be sure. This is 10, 22, 24. Good. This is meant to be chromium. But the electronic configuration is not 28102. The electronic configuration is 28131. 28131. It is because of the rule, because chromium and copper are stable, right? So that rule 28131. But for copper, it is, if we continue to go, this does not mean that the next one will be 28141. It will still continue normally. You will now have 28132, 28142, just like that, 28152, 28162. So let's say we have 28162. Which one is this one? This is 1028. Okay, let's say 28172. So this is meant to be the electronic configuration of copper. This one 28172. But then copper electronic configuration is 28182. These are the two exceptions. 28181, sorry. These are the exception, copper and chromium. Which means that if this is K, this is L, this is M, and this is N, this is meant to be 4s, right? 4s, which means that 4s has how many electron? One electron. Which option has one electron? 4s. B. It's as simple as that. It's as simple as that. Just in case you don't understand, ensure you look at that crash course material. I'm begging you. 35. The energy released when an electron is added to a gaseous atom is called electron affinity. So there's something you should take note of. Electron affinity is more like the opposite of ionization energy. All right. Electron affinity, it is added. Ionization energy, it is removed. So if you remove, what is the energy released when something is removed, or when is the energy absorbed when something is removed? Ionization energy. Then when you added, electronic affinity. Okay. As we move down a group, electronegativity generally decreases, right? Electronegativity decreases. So you should take note of, if you look at the halogens, you know the halogens are more like, that's where we have equatars of electronegative elements. We start with fluorine, right? Then we have chlorine, then we have, just like that, it continues like that, bromine, iodine, and stuff like that. You see that fluorine has the higher, or the highest electronegativity, followed by chlorine, followed by, just like that. So you see that the electronegativity is decreasing down the group. The next one we have, which block contains lanthanides and actinides? You should take note, it is the F block, right? And one thing you should take note of is that they are inner transition elements, right? Lanthanides is from 57 to 71. That's lanthanides. Though it's not, I'm not sure you will come across something like this, but then just still put it in mind. Why actinides is 89 to 103. All right, so let's move on. 38. Whose rule of maximum multiplicity states that electrons occupy orbitals singly before pairing? Remember I said it is still the same guy that has to do with degeneracy, same energy. So if we have something like this is an orbital subshell, it will first of all pair, it will first of all occupy singly. So we'll have something like this singly first, then it's now what? Pair. So what gives, or the person that postulated this law is Hund, and it's known as Hund's rule of maximum multiplicity. Question 39. Which ion is isoelectronic with argon? That's argon is 18. When you see isoelectronic, it's just telling you that which ion has the same electronic configuration as a normal element. That's what it means. Remember, sodium is 11. Sodium plus, remember, since it's 11, it's going to be 10. Oxygen is 8. What is this? It's gaining 2, which means it is 10. Calcium is 20. 2 plus, which is losing 2, which means it is 18. You can see it resembles this. So the correct answer is calcium. When you see questions like this, they're very simple and sweet. Just pick the answer and go. 40. The screening effect results in this screening effect has to do with ionization energy. For short, when you see screening effect, that's the way ionization energy. So if you look at the option, which option is connecting ionization energy? This is the decreased ionization energy. But then let me just explain it in case you come across question like this and then not the option has electron or ionization energy. Okay, so this is what it means here. If you have something like this is a nucleus, you have a particular shell like this, you have a particular shell like this, you have a particular shell like this. You remember ionization energy? I said ionization energy is when you remove, right? So if this is electron A and this is electron B. Which electron do you think it will be easy to remove? It is electron A because electron A is very far from the nucleus. So the nuclear charge is just there. So you can easily remove A, or B is the force of adhesion, the strength. You will not easily remove B, but you can quickly just remove A, just throw away A one side, right? But then if this screening effect, you continue to add more shells. That's the screening effect. If you're adding more shell, what is happening? The ionization energy is what? Is decreasing. Is decreasing. But then if you are removing shells, if you are removing shell, the ionization energy is what? Is increasing because it will take more energy to remove the electrons. So that's what is known as screening effect or shielding effect. 41. Which group 18 elements are called noble gases? Okay. This kind of question we get answer for the question. Noble gases, right? Group 18. When you hear group 18, just know it is the normal group 8 for your periodic table in secondary school. Okay, please take note. The 10, the additional 10 is coming from the transition element. 42. Shape of an s orbital is spherical. This is another question that you must take note of. Shape of orbitals. D orbital, F orbital, you know the shape. Everything has been talked about in the crash course. Which period 2 element has the highest ionization energy? Period 2. If you look at all these things, in fact, you can even know the answer to the question sef even without knowing the concept or knowing anything. Alright. If you look at it, they said period 2. Period 2. All these things here, one thing you should take note about ionization energy is if you have something like 282, you can use ionization energy to know, you can use electronic configuration rather to know ionization energy. 284, then we have 288, 288. Now, what do you think, or which one do you think will be easy to remove? It is 282. You can easily remove 282 compared to removing 288. You understand what I mean? You can easily transfer, maybe you want to bond now, you can transfer 2 electron to another element rather than transferring a whole 8. So in this 282, the ionization energy is what? Is low because you can just easily remove it. You don't need so much energy. But in 288, oh my God, you need to put energy before you can even remove it, if that is even possible. If you look at neon now, neon is 10, right? We have 28. For you to remove 8, oh my God, you will sweat. So neon is going to have the highest ionization energy. It's as simple as that, right? The azimuthal quantum number for p subshell, this is another thing you must take note of. The azimuthal quantum number for p subshell is 1. Okay, remember what we said about azimuthal quantum number. So S is 0, P is 1, D is 2, and then F is 3. These are these things you should take note of them. Question 45. Alkaline earth metals belong to group 2. Please take note. Alkaline earth metal and alkali metal, they are two different things. Alkaline metal is group 1. Alkaline earth metal is group 2. Okay. Effective nuclear charge across a period. Effective nuclear charge across a period increases. It increases. Okay. It increases. So basically, more protons with same shielding increases pool. But then let me not just confuse you. What happens is that because there is a decreasing, remember across the period, the atomic radius decreases. We talked about it in one of the questions. The atomic number decreases. And this nuclear charge and atomic number, they have more like an inverse relationship. So as one is increasing, the other one is doing what is decreasing. So that's why it increases. But then all of these trends has been illustrated in the crash course file. Just go there and learn it. 47, the formula 2n square. Okay, this one is very common. 2n square tells us the maximum electrons in a shell. All right, remember the principal quantum number tells us the shell. Okay, 48, which of the following is a metalloid? Metalloid are those elements that show both metallic and non-metallic properties, and we have silicon. All right, the other metalloids, please take note. So metalloid have this kind of zigzag line in the periodic table, zigzag line. So if you see any question that says which group of elements have zigzag line, it is metalloid. Okay, take note of that. Then the next one we have, after 3p in Alval sequence comes, remember it is S, P, D, and F. This is the normal one. So normally you can say after 3p is 3d, but then it is wrong. That is where alpha principle comes. Alpha principle says that you are arranging from lowest to highest, and that is why it's very important for you to know this. There's this diagram that looks like this: 2s, 2p. I know many of you should know this diagram: 3p and then 3d, right? Then we have 4s. So just like that. So if you want to get it now, the first one you strike 1s, you go up 2s, you come down 2p, right? Just like that, 3s. Then when you go up again, when you go up, you have 3p. Then as you're coming down, you are meeting 4s. So after 3p is 4s, not 3d. Please take note. And there are other exceptions. Just know this diagram and you're good to go. Okay. Question 50. Valence electrons are found in the outer shell. I've been talking about that. They are found in the outer shell. They are found in the outer shell. Okay. Hybridization. A very, very sweet topic. All right. So hybridization is one important topic that you must expect if you'll be preparing for CHM101 examination. Okay, so let's move on. All right, all of these things, all of these topics we are treating now in this video, everything is in the crash course. Okay, 51. Which type of hybridization is found in a carbon atom that forms four single covalent bonds, such as methane? Right. Another thing you should take note of is that you'll be seeing questions like this. They will tell you what type of hybridization. Okay. Basically, how this hybridization is formed, it has a process. All right. Now, this process, if you because of the nature of your exam, you don't really need to cram the process. All right, because trust me, if you really want to know the process, then there are a lot of complex things regarding the process. You see some things like this. I don't know if you must have come across it in some textbook. You see something like this, then you see something like this, and they'll just tell you this is SP3 or this is SP, and you just be, how come? How did they just look at this kind of structure? And just, so all those things is going to waste your time, right? Because of the nature of exam you are preparing for, you don't need to bore yourself with all these plenty diagrams that you might be seeing in your textbook. There is a formula or there is a code. Once you know that code, you are good to go. Now, if you look at methane, methane has this kind of structure. You agree with me that this is the structure of methane, right? This is how methane looks like. Methane looks like this. Then you have H here, right? Then you have H here, and you have H here. You have H here, and then you have H here. So now the type of bond that is available determines the type of hybridization. So what am I trying to say? It has a process, right? Like I said, but then there's a code that you need to just know. Once you know the code, you are good to go. Any type of hybridization they ask you in your exam, you'll be able to answer it. All right. Now, this code is not associated with the process. Okay, it is just a code for you to remember the hybridization. And when you see four bonds, right? If you see four bonds, all you need to do is to look for the option that is four. Right, look for the option that is four. And basically, the kind of hybridization that you'll be seeing on your exam, most likely for your level, is SP. Either is SP, SP2, SP3. Right? They will not bring complex hybridization for you. Now, once you see something like this is four. If you look at option C has four letters. What am I trying to say? Remember this SP3 in mathematics, you can write SP3 as S, then P three times, right? That's what it means now. P three times, which means that the total number of letters here is four. Why? Four bond. So if you have something like, let me say, for example, if you have something like this. Now, the kind of hybridization that you should be expecting is no longer going to be SP3 again. But then, let's proceed. As we proceed, you understand the concept I'm talking about. But then, all the codes, everything has been highlighted and discussed in that crash course, okay? 52. What is the ideal bond angle in a molecule with SP2 hybridization? So another thing that you'll be taking note of is the angle, okay? The correct answer is option B, 120. So as the hybridization determines the type of bond. So this hybridization is for sp3, then this is sp2. Then when it is 180, it is sp. Alright, so you will now see something like this. It's going to be straight. You see a bonding that looks straight like this. Once you see a bonding that looks straight like this, you know this is 180-degree in mathematics, right? When it is straight, angle on a straight line is 180 degree. Okay, but then the question is sp2, which is 120. So moving on. A sigma bond, good. This is another kind of question that you should be expecting under hybridization. Sigma bond and pi bond. They'll just ask you how many sigma bonds are here, how many pi bonds are here. All right. There's a code also, and that code is if it is one bond, you have one sigma, one sigma. This is the sign of sigma. If it is double bond, you have one sigma and one pi bond. You know what pi is now? Pi, the shape of pi. Don't worry, when we get to questions like that, I'm going to highlight it. But now, how this sigma bond is formed, like I said, there's a process. That process is head-on overlap. of atomic orbital along the internuclear axis. Like I said, it's a very complex process, but then just take note of this. Sigma bond is formed by this. All right. So the next question, 54. Which of the following molecules has a linear shape? Now take a look at this. Which molecule will most likely have a linear shape? Now you might want to think it is water, but trust me, it is not water. Water does not have a linear shape. The structure that has a linear shape here is CO2. So CO2 in CO2 bonding. CO2 bonding looks like this. This is how CO2 bonding looks like this, like this. And that is why it has something like a straight line. It has a linear shape. But water is like this. H2O. Water is like this, and you have O here, and then you have O here, right? Then you have O here, like this. This is how the bonding is. So it is bent. The correct answer is C. Next question. According to DSEPR theory, you will see that in your textbook. Okay, which of these has the strongest repulsive force? Right. The correct answer is lone pair, lone pair. Lone pair has the strongest repulsive force. Right. Lone pairs repel strongly because they occupy more space, right? So because of that, there's nothing bonding with them, so there's space. So imagine lone pair and lone pair now combined together, it's going to have the strongest repulsive, right? 56. What is the hybridization of boron in BCl3? Now, BCl3 is something like this. So it looks like this. That means boron is bonded to chlorine in three places. So you have chlorine like this, then you have chlorine like this, and then you have chlorine like this. Now, if it is three bond that you are seeing, you go for three letters. Remember the code, but then the code has been explained in your crash course, right? So three letters. Which of the following is three letters? This is definitely three letters. If you expand it, S, P, and P, right? Three letters. It's as simple as that. Okay. A triple bond consists of good. This is where I was coming to. A triple bond consists of one sigma bond and two pi. One sigma bond and two pi bond. Right? One sigma bond and two pi bond. Please take note. So if they say a triple bond consists of what? One sigma bond and two pi bond. There is nothing like three sigma. Okay, please take note. Double bond, single bond has one sigma, right? One sigma. This is not the sign for sigma. This sign for sigma. One sigma. Double bond has one sigma, right, and one pi. Then triple bond has one sigma, right, and two pi and two pi. Which type of orbital overlap creates a pi bond? Remember we talked about how sigma bond is formed. Now how a pi bond is formed? A pi bond is formed by sideways overlapping. Okay, sideways overlapping. There's a structure I drew before. It was not the exact structure, but then it's just looking like, let me just give an example. This is what they call sideway. You can see these guys, they are bonded together by their side. When something like this comes together, when there's an overlapping of the p orbitals sideways, it forms pi bond. Okay, like I said, you don't need to bore yourself with the complexities. Just know which one and which one forms which one. Then go and smash the exam. 59. What is the molecular geometry of PCl5? This is another thing that you should take note of. Right? They will tell you the shape. When they say molecular geometry, they're trying to tell you that what is the shape of that particular compound, right? Now, once you see anything above 4, or maybe it is 5, just know it is trigonal by pyramidal. Try 3 by 2 equals to 5. It's as simple as that. It's just simple logic. Okay. 60. In sp3 hybridization, how many p orbitals are mixed with s orbital? Remember the same mathematics we did. How many p orbitals? See here, p3. So how many? 3. It's as simple as that. Very simple and interesting. Right? 61. Which molecule has a bent geometry? Remember I said that the molecule that has a bent geometry before or V is what? H2O. Now if you look at all this structure, which of the following looks like H2O here? It's definitely hydrogen sulfide, H2S. So it will have a bent structure, right? 62. Which of the following contains a dative coordinate covalent bond? Okay. So now when you hear covalent bond, there are various types of covalent bond. One of the covalent type of covalent bond is dative, right? So when we hear dative has to do when you see anything that contains a ion in your exam and they say what type of bond is this, just run and pick what dative. So if you look at this is a dative covalent bond. So in a dative covalent bond, okay, there's a question like that. Let me know explain it. When I get there, I'll explain. What is the bond angle in the tetrahedral molecule like methane? Remember, methane is what? Before you can get angle, you need to get the type of hybridization. Methane is sp3. And I said something about sp3, that sp3 is 109.5, sp2 is 120, then sp3 is 180. Alright, please take note of that also. The hybridization of carbon in 18, this is it, 18, this is 18 here. Right? The hybridization for 18, once you see double bond, your mind should just go to sp2, right? If you see single bond forming 4, it is your sp3. If you see double bond, sp2. If you see triple bond, it is sp. Right. So if we should get the structure of this, we'll have something like this. We'll have something like this. Then H here, then H here, and then H here. Now, the hybridization is just one carbon. If you look at this now, if you look at this carbon here, you see it's bonded to another carbon, 2 bonds, right? But then if you count the bonds there, because carbon is always 4 bonds, right? But now this double bond is not going to be counted as 2 bonds, it's be counted as one for the sake of this formula. So if you count this as one, it will be 1, 2, 3. And remember, I said it is 3 bond, you go for the one that has 3 letters, right? sp2. If it is triple bond, this is what I'm saying here. If it is triple bond, for example, triple bond will look like this. Then you count this triple bond as one. So if you pick one carbon, 1 bond, 2 bond, how many bonds? 2 bond, which makes the which makes the hybridization sp, right? Next question: which geometry is associated with sp hybridization? Okay, so you know the geometry that is attached with sp2, sp3, right? So the one that is attached with sp is linear, right? Linear. Then next we have chemical bonding and chemical reaction. Okay, so chemical bonding and chemical reaction. I think okay, this is not the last. The last is radioactivity. So let's go. Which type of bond is formed by the complete transfer of one or more electrons from a metal to a non-metal? When you get transfer of electrons to form a bond is known as ionic or electrovalent bond. Right. So which of the following substance has a high melting point and conduct electricity when melting? The correct answer is B. What they are just trying to tell you is which of the following bond has electrovalent, which of the following compound has electrovalent bond? Because one of the characteristics of electrovalent is that they have high melting points and also they conduct electricity when melting. And if you look at this, this is the only bond that is what? Electrovalent. This guy here is not electrovalent, this is not electrovalent, and this one too is not electrovalent, right? So next question. A covalent bond in which one atom supplies both electron is known as dative, right? It is known as dative. So remember, dative was the one I said that you will see ion. Once you see ion, a sign plus or minus, they tell you which bond is here, just know that it is your dative bond. So basically what it means is that one atom will be the one to supply both electrons, right? That is why it is always seen in an ionic state, either plus or negative, because it's supplying what the both electrons. 69. Which molecule contains a non-polar covalent bond? When you get non-polar covalent bond, when an element combines together with itself, it forms a non-polar covalent bond. So the correct answer is chlorine. Chlorine. So 70. The C of mobile electrons model explains the properties of metals. Alright, that is the reason why metal conducts electricity, because in metals, let me see if this is a particular metal. In metals, you see so many electrons, free electrons, so many, and they are moving. Alright, so because of these electrons, the way they are moving along the metal makes it conduct electricity. Okay. So metals have free electrons. So because of their free electrons, they can conduct electricity. Right? 71. So now this is calculation. Molar mass of CaCO3 is equals to 100. Now let me tell you how we got 100. To calculate molar mass, no, molar mass calculation is the simplest calculation of them all. Calcium is 40, right? So it's just basically you adding the atomic masses, right? So 40, this is carbon here. Carbon is what? 12. They have given us in the question. Then this is O3. What is O? 16. And O is 3. So that is 16 times 3. And 16 times 3 is equals to 48, right? So by the time you add all of this, you get 100. So please, if you see molar mass in your exam, be very, very happy because it's very simple to calculate, right? 72. Moles in 5 gram of hydrogen in hydrogen gas. Remember, moles, the formula for moles is equals to mass over molar mass. That's the formula for mole. Now, what is the molar mass of hydrogen gas? The molar mass of hydrogen gas is 2. Remember, hydrogen is 1 and H2, that is 1 times 2, 2. Which gram were we given? We're given 5, which means that the mass that we're given is 5. 5 divided by, what is the molar mass? The molar mass is what? 2. So what is the answer? 5 divided by 2 will give us 2.5. So the correct answer is 2.5. 73. Empirical formula. Please, formulas, you take note of formula. We have empirical formula, we have molecular formula, we have structural formula, and other formulas. But then for calculation, the formula you take note of is empirical formula and molecular formula. So empirical formula is the simplest formula. Like this, now if you see CH2, CH2 cannot be broken down again, right? But molecular formula, some molecular formula can still be broken down. So the question is, there is a particular compound from all these options here that the molecular formula is CH2 and the molar mass is 42. It is very, very simple, which means that CH2 is the smallest form of that formula, right? So you have something like CH2 N is equals to 42. How do you get CH2? Remember, C is 12 and H is 2. That's 14N. So you have 14N. 14N is equals to 42. So you divide both sides by what? 14. So 42 divided by 14. That's going to give us 3. So this means that this N here is going to be what? 3. So if this N is 3, C is going to be 3 and H is going to be what? 6. So our correct answer is B. It's as simple as that. So please practice more questions regarding all of these calculations we are doing. 74, mole ratio of hydrogen to water in this equation. So this is the equation here. This one is very, very simple. So what is hydrogen? Hydrogen is 2. Water is what? 2. So this is hydrogen. Hydrogen is 2 and water is 2. So the correct answer is 2 ratio 2. But now something you must take note of is that in mathematics, you can't, this is not the ratio because ratio is the smallest form. And what's the smallest form of this? This is 1 ratio 1. You can see how tricky this question is. 2 ratio 2 is in the option, 1 ratio 1 is in the option. Correct answer is 1 ratio 1. 75. Avogadro's constant. This one is very easy. You should know this is Avogadro's constant. 6.02 times 10 raised to 23. 76. The volume of 1 mole of gas at STP. You should know this also, which is 22.4 liters. 22.4 liters. You know, liter is the same thing as dm cube, right? Now, the reactant that limits product formation, okay? The reactant that limits product formation, that means in the process of a product being formed, there's a particular reactant that tries to stop the product from being formed. It is known as limiting reactant. So reaction stop when the limiting reactant is used up. So after the limiting reactant has been used up, the reaction stops. Okay. So next question. 78. Percentage oxygen in H2O is the percentage of oxygen in H2O. This is very simple. To calculate percentage of oxygen, first of all, we need to know what H2O is. H2O, remember H2 is 2 plus 16, right? Plus 16. So this is 18. 18. What is oxygen? Oxygen is 16, which means 16 divided by 18 times 100. This is how to calculate percentage for any element in a particular compound. So if you do this calculation very well, you get 88.9%. 88.9%, right? 79. High boiling point of water is due to its hydrogen bond. So the reason why water has high boiling point is because of hydrogen bond. Percentage yield if actual is 8 and theoretical is 10. So a particular gram, the actual gram is 8, right? But now in the theory, in the written form, they wrote 10. What is the yield, the percentage yield? How to get percentage yield? The formula for percentage yield is the actual divided by theoretical. So actual divided by theoretical times 100. That is it. So actual divided by theoretical, if you do this very well, you get 80%. If your percentage yield is more than 100, please, your calculation is wrong because the percentage yield is always less than 100. 81. Which is a property of covalent compound? A property of covalent compound is low melting point. Remember that electrovalent has high melting points, but covalent has low melting point. Remember that electrovalent and covalent are somehow like one and opposite. One is transfer, that is electrovalent, while covalent is sharing, they share the bond. Number 82, number of atoms in 0.5 moles of carbon. So when you see this kind of question, just all you need to do is multiply this times Avogadro's constant. To get atom, when they say number of atom plus something, it's just trying to tell you that you need to multiply it by Avogadro's constant. So by the time you do this calculation, you multiply by Avogadro's constant, you're going to get 3.01 times 10 raised to 23, right? 83, coordinate covalent bond is also called dative, right? We have talked about this in 2 questions now. Dative. 84. Endothermic reaction. In endothermic reaction, what happens in endothermic reaction? In endothermic reaction, heat is absorbed. Please take note of that. All right, heat is absorbed. Why in exothermic, heat is released. Okay. Empirical formula of benzene. Remember, I said empirical formula is the smallest form. So if you divide this benzene formula, 6 can go here. That's going to be C. 6 can go here. That's going to be H. So the smallest formula is CH, and that is option C. All right. Next question, we have radioactivity. Now, radioactivity, there are a lot of interesting things in radioactivity. Everything is in the crash course. Okay, so please do well to access that crash course so that you understand better some of these concepts that I am explaining right now. Okay, so I'm going to be releasing the crash course is free. Everything I'm releasing is absolutely free. Okay, so please do well to reach out to me. So if you have watched to this point and you want me to be dropping subsequent videos, remember I said this video is 3 sections, so I've dropped one, remain 2. Please, if you want me to still be dropping more, please do well to hit the subscribe button. So if you have watched to this point and are not yet a subscriber, because According to my YouTube analytics, it shows that a lot of persons that watch my video are not subscribers. So please do well to support me by subscribing to this channel. Okay. Now, radioactivity is best defined as the spontaneous disintegration. This one is simple. Spontaneous disintegration. If you see this kind of question, you should not fail it. The definition of radioactivity: spontaneous disintegration. Which of the following radiations has the highest ionization power? Good. So another thing you take note of is the characteristics of radiation. We have alpha, we have beta, we have gamma, we have X-rays. Okay, you should know their ionization power, you should know their penetrating power, and other things. You should know everything, wavelengths, all those things. Everything has been summarized in the crash course material. Okay, so the answer is alpha. Alpha has the highest ionization power because they are heavy and then they are highly charged. So because of that, they will have high ionization power. During alpha decay, mass number and atomic number change by. So in alpha decay there is a removal of helium molecule. So you'll be seeing some interesting questions like this. So in alpha decay, there's removal of helium molecule. So this thing is going to be removed from a particular structure, from a particular element rather. So now remember that I said the up is mass number. And what is the up? The up is what? A, right? And the down is Z. So if we are removing, what does that mean? A minus 4, Z minus 2. Which option has that? That's option B. If it is beta, this is for alpha. If it is beta, beta is like this. This is how beta is. This is how beta is. Beta is like this. So the mass number will still be like that, but the atomic number, one will be added. Remember, when it is minus 1, it is not removal, it is addition. Please take note. Then when it is positive, it is removal. Remember the ion where we talked about A plus and then we talked about E minus. Remember that, right? Please take note of that. It's like which radiation is not deflected by electric or magnetic field, right? The answer is gamma, right? So you see something like this, see something like this. Well, some radiation will deflect, some will deflect to this side. So you have positive here, you have negative. One will deflect here, one will deflect. Then there's one that will not deflect at all. That is gamma. Gamma does not deflect. You should know the one that will deflect to positive, and you should know the one that will deflect to negative. Everything has been talked about in the file. Okay. 90. The time for half of radioactive atom to decay is known as half-life. So a calculation that you might be seeing in radioactivity is half-life, and you should know the half-life calculation. Okay. Number 91. Which is nuclear fusion? When you hear nuclear fusion has to do with combining, joining. Then fission, like this. If you see fission has to do with breakdown, right? When they say uranium splitting, that's fission because it's breaking down. Hydrogen nuclide combining to form helium, that is fusion, combining together, right? So the correct answer is option B. 92. During beta decay, now see remember the one we did was alpha decay. Now during beta decay, the atomic number increases by 1. We have explained that before, that the atomic number will increase by 1. Okay. Half-life problem. Okay, this is a half-life problem, and this is it. The half-life of a particular element or a particular substance is 10 days, then it is 40 gram. After 30 days, what will it be? Calculation of half-life is very simple, which means after 10 days, this 40 is going to be half, right? So it's going to be what? It's going to be 20. After another 10 days, it will be half again. That will be 10. How many days now? 20 days, right? Then on the 30 days, this 10 will now be what? Will now be 5. So the correct answer is 5. So this is the easiest way to calculate half-life. Though calculation for half-life, there's one complex formula like that because you have to differentiate, integrate, do a lot of calculus. But for now, this is just the easiest way to solve it and for the nature of the exam you are preparing for. Carbon dating uses which isotope? Carbon 14. Please take notes. Don't go and cram carbon 12 too much and then pick carbon 12. It's carbon 14. Okay. Which radiation is stopped by paper? Which radiation is stopped by paper? The radiation that is stopped by paper is alpha. Remember, I said you should learn their ionization energy, you should learn their penetrating power also. 96. Instruments used to detect radiation is known as Geiger Muller counter. 97. Nuclear force is responsible for holding the nucleus together. When you hear nucleus, it's holding the nucleus together. All right. 98. Artificial radioactivity was discovered by Julius Curie couple. Right, which means that there is a natural radioactivity. Okay. Natural radioactivity was discovered by this guy, Maria Curie. Please take notes. Rutherford and Doubting, nothing concern them concern radioactivity. Okay. 99. Which isotope is used in cancer? Another thing you should take note of is the usefulness of isotopes. Usefulness of isotopes. This falls under radioactivity. The correct answer is cobalt 60. Okay. Then 100. The last question for this video. What is produced when this is what you see some questions like this? This guy here undergoes beta decay. Nothing concern you concern all these options. So you don't really need to know the elements they are. It's not your business. Just know how to calculate it. For beta decay, you should know beta decay is 0 minus 1 E, right? 0 minus 1 E, which means that this under here is going to gain 1 electron. And if this under gains 1 electron, it will become what? 91. B. Right, so I've come to the end of this video. Just in case you enjoyed this video, please do well to hit the subscribe button as usual, share with your colleagues, share to your departmental group chat, all right, and anticipate the section 2 of this video. And as usual, I'll be dropping the section 2 when I see that this section 1 has a lot of engagement. So do well to share it with your friends. Don't hide the updates, ensure you share it. All right, so see you guys in the next video. Bye for now.